Good evening. This is Professor David De Los Reyes. Okay, my topic for tonight will be a continuation of my subject matter, trigonometry. It's a long video format discussion. So for tonight, it's November 18, 2023, and the time is almost, what time is it? 11:50 p.m. So for tonight, I will be discussing proving general identities under the study of trigonometry. Okay, let's proceed. The subject matter for tonight, for those of you who are following my trigonometry long video format discussion, this is trigonometry lesson number 25, and the title of the topic will be proving general identities. One of the most important topics under the study of trigonometry will be our knowledge on identities. And one of the variation of problems under identities is the so-called proving of identities. The other important consideration of identities is actually when we reach integral calculus, we will be, what you call this, using our knowledge of identities in the so-called integration involving powers of trigonometric functions. But for tonight, this is just plain trigonometry, so we will be discussing proving general identities. Proving general identities. An example of identity is actually sine square of alpha plus cosine square of alpha is equal to 1. This is the one of the basic identities. Without knowing this, it seems you don't pass through trigonometry. So when you hear sine square of alpha plus cosine square of alpha is equal to 1, that's a trigonometric identity. Okay? Let's try to bring out the rule or process and how to prove general identities. There is a rule which must be followed. And I just summarize it into 4 things. Number 1, the rule on how to prove general identities. Manipulate the complicated side. There should be a complicated side, CS. You'll try to manipulate on the complicated side. The hint here is number 1 step is identify the complicated side and try to make manipulations on the complicated side. Okay. Number 2, stop manipulating when the complicated side is equal to the side not complicated. Not complicated. The rule here is try to manipulate the complicated side. So after doing so many, what they call this, manipulation, okay, try to look for the value of the complicated side if it is now equal to the value of the not complicated side, if they are now equal, right? So while you are manipulating on the complicated side, maybe after so many steps, try to compare the value of the complicated side to the not complicated side. If they are not equal, or if they are now equal, stop. The hint here is stop. Stop manipulating because you have proven already the identity. They are now equal, right? So number 1 step, what they call this, determine which side is the complicated one. Try to make manipulations on the complicated side. And after so many steps, if the complicated side is now equal to the not complicated side, if it is now equal, okay, we have proved already the identity. And as an additional thing, before going to the stopping process, number 3, always place a question mark on top of the equality sign when the equality is not yet reached. Meaning, while you are manipulating the complicated side, always place a question mark. Because you are asking yourself, is the left hand side equal to the right hand side now? Or the complicated side equal now to the not complicated side? You're asking yourself. Because you can see it, if they are now equal, stop manipulating. You have proven already the identity. Okay? So number 4, after reaching the equality, meaning when the complicated side is now equal to the not complicated side, you remove the question mark and you have proven already that the identity are equal. So for step number 4, after reaching the equality, remove the question mark. Remove the question mark. If you reach equality, there's an equality, right? But if on the next step, they are now equal, try to remove the question mark. Okay? So after reaching equality, remove the question mark and place QED. Place QED. Meaning, if they are now equal, try to place QED beside it. And you have proven the, what you call this, equality of the identity. Meaning the complicated side, after so many manipulations, is now equal to the not complicated side, so we place QED beside it. And the meaning of QED, oh, this is just a mathematical, what you call this, designation, QED. I think this is a Latin word if you try to Google it. The meaning of QED is Quod erat demonstrandum, or in English, which was proven to be, or which was to be demonstrated. The meaning of QED is Quod erat demonstrandum, or in English, which was to be demonstrated. It seems it was proven to be true. After the manipulations, it was proven to be true that the complicated side is equal to the not complicated side. So that's the rule on how to prove general identities. Okay, let's try to bring out an example number 1 so we could visualize the significance of the rules on how to prove general identities. I would like to erase this one. This is garbage here. Example number 1. Prove we are given an identity. Tangent of alpha plus cotangent of alpha equal to secant of alpha, cosecant of alpha. We must have to prove that tangent of alpha plus cotangent is equal to secant alpha, cosecant of alpha. Okay, so the first step here, according to the rule, is try to take note of which is more complicated, the left hand side or the right hand side. I think the left hand side is more complicated than the right hand side. So we'll try to make manipulations on this and we'll leave the right hand side as it is. Okay, so if we now try to bring up the solution, the left side is more complicated. So we don't touch the right hand side. We will just rewrite it as we move on. Okay, so it should be something like this. Tangent of alpha. We now try to make manipulations, make some substitutions, try to make some replacements by using your knowledge of the definitions of the different trigonometric functions. Tangent of alpha is actually the ratio of sine of alpha over cosine of alpha. Tangent is sine over cosine, right? You are not violating anything about it. How about cotangent? Cotangent is the reciprocal of tangent. It is cosine of alpha over sine of alpha. Is it equal to? We got a question mark here. Equal to, is it equal to? We got a question mark. The right hand side, we don't touch it. This is the not complicated side, right? So we just rewrite it. Okay? Then try to make some algebraic manipulations on the left hand side. That's why on the complicated side, try to make some substitutions or try to make some algebraic manipulations. Right? So if we try to make some algebraic manipulation on the left hand side, this is now what we call this a study of algebra. We try to combine sine over cosine plus cosine over sine. The denominators are different. So we will be using the butterfly method. It will be the product of this plus the product of this, and the resulting overall denominator will be the product of the first denominator times the second denominator. And if we try to simplify this, sine of alpha times sine of alpha is sine square of alpha, and cosine of alpha times cosine of alpha will be cosine square of alpha. It's now quadratic all over. The common denominator now will be, we're using the butterfly method. We are combining two fractions with different denominators, but unluckily, our fractions are actually trigonometric functions, right? So there's a catch. It's not just a plain algebraic, it's a trigonometric function. So this will be sine square of alpha, cosine square of alpha. The product of cosine and sine will be sine of alpha, cosine of alpha. Okay? And is it equal to? We place the question mark equal to secant of alpha, cosecant of alpha. We are asking ourselves, are they equal now? Not yet. Okay? Then try to make some substitutions again by using your knowledge of trigonometry. What is sine square of alpha plus cosine square of alpha? That is actually equal to 1, right? Okay, so we could replace this sine square of alpha plus cosine square of alpha by equal to 1. So this is now 1 over sine of alpha, cosine of alpha. The operation is multiplication, right? Is it equal to secant of alpha, cosecant of alpha? Okay. The left hand side could be rewritten as, okay, the product of two fractions, right? The operation is multiplication. So 1 over sine alpha cosine of alpha can be written as 1 over sine of alpha times 1 over cosine of alpha. Is it equal to secant of alpha cosecant of alpha? Okay? Then again, try to bring out your knowledge of the so-called reciprocal functions under the study of trigonometry. What is 1 over sine of alpha? That is actually cosecant of alpha. And what is 1 over cosine of alpha? That is actually secant of alpha. So the operation here is product, right? So 1 over sine will be cosecant times 1 over cosine of alpha, which is secant of alpha. So actually we are multiplying cosecant and secant, right? So cosecant of alpha times secant of alpha. The operation is multiplication. Is it equal to secant of alpha, cosecant of alpha? Rearranging terms on the left hand side, we rewrite first secant of alpha. So secant of alpha, anyway the operation is multiplication, we could interchange the location, right? So secant of alpha times cosecant of alpha is now equal to secant of alpha, cosecant of alpha. We remove now the question mark, okay? Since they are now equal, okay, we remove the question mark here. And we have proven that the left-hand side is equal to the right-hand side, so we place QD. It was proven to be true, or which was to be demonstrated, or quod erat demonstrandum, the meaning of this. It's a Latin word. We have proven that the complicated side, after so much manipulations, is now equal to the right-hand side, which is secant of alpha, cosecant of alpha. Okay, seems interesting. I think so, right? Example number 2. Prove that tangent square of alpha will be equal to sine square of alpha plus the product of sine square of alpha times tangent square of alpha. We must have to prove that the left hand side is equal to this. By inspection, the more complicated side is the right hand side, right? So I place it here. The right side is more complicated, so we don't touch the left hand side. We'll just make manipulations on the right hand side. So tangent square of alpha is equal to. Try now to make some algebraic manipulations. Whatever manipulation you will need it to make some algebraic manipulation, do it, right? I think the first thing that we should do is for the right hand side. There is a sine square of alpha, so we bring it out. So this should be sine square of alpha times open bracket. This is 1. 1 times sine square is this one. We factor out sine square of alpha, so what remains inside will be tangent square of alpha close bracket. Right? The product of this is the second term, and the product of 1 and this one is the first term. Okay? Then try to make some substitutions by using your knowledge of trigonometry. 1 plus tangent square of alpha is actually secant square of alpha. So we could replace 1 plus tangent square by the value secant square of alpha. So tangent square of alpha, is it equal to? We maintain sine square of alpha, and we replace this value here by secant square of alpha. Okay, secant square of alpha. Tangent square of alpha, is it equal to? Again, try to do some manipulations. Try to make some substitutions. Okay. We'll maintain sine square of alpha. Secant square is actually secant of alpha is actually 1 over cosine of alpha. Right? Secant and cosine are reciprocal. So if we square this one, we square also this one. So we could replace secant square of alpha or 1 over cosine square of alpha by secant square of alpha. So it will now be sine square of alpha times the equivalent of this will be 1 over cosine square of alpha, right? It's the reciprocal, secant is the reciprocal of cosine, but this is square, so this should also be square. So tangent square of alpha is it equal to? We will rewrite sine square of alpha as the product of sine of alpha times sine of alpha, right? Sine of alpha times sine of alpha is sine square of alpha. And actually, we could rewrite this one as a product, 1 over cosine of alpha times 1 over cosine of alpha. Right? So I could rewrite this one as two terms involving the product of 1 over cosine of alpha, that is 1 over cosine of alpha times 1 over cosine of alpha. Cosine alpha is actually cosine square of alpha. Then I will try to combine this one here and this one. It will be this. Right? And I will try to combine this one with this one. It is this. The operation is multiplication. Right? So tangent square of alpha is it equal to? The right hand side will now be, after the combining of sine of alpha and cosine of alpha, this is now cosine, sine over cosine, sine over cosine. Okay, but what is sine over cosine? Sine over cosine is actually tangent. Right? Sine over cosine is still a tangent. Is this equal to tangent square of alpha? Okay? Therefore, tangent square of alpha, this is alpha. Equal to tangent of alpha times tangent of alpha is tangent square of alpha. Is it equal to? But they are now equal, right? So we remove the question mark, okay? And since they are now equal, therefore tangent square of alpha is equal to tangent square of alpha after these manipulations on the right hand side. And we place beside it QAD, which was to be demonstrated or code erat demonstrandum, the meaning of this one. The significance of this, while we are proving identities, if we have proven that the identities are actually correct, we place QAD beside it, meaning code erat demonstrandum, or which was to be demonstrated. Okay, that's the way how to prove general identities. So we will be using our knowledge of the different definitions of trigonometric functions. We do some algebraic manipulations using our knowledge of algebra, and that's it. Okay? Okay, I think this is more than good enough for the demonstration on how to prove general identities. Okay, good evening or good morning from Los Angeles. This is Professor David Jetros.